This is Mrs. O'Neill for AP Chemistry, Chapter 8, Section 6, Resonance Structures, which we've already touched base with already. So there are some objectives here. Observe that in some cases more than one equivalent Lewis structure can be drawn for a molecule or a polyatomic ion. And of course, because of that, there's called resonance structures. So what is resonance? Again, I suggest you pause, fill in the blanks, and then play to hear my words. Sometimes there is more than one valid structure for a molecule, and we are going to draw double arrows between those structures to indicate that there's an average of those structures. So in other words, and it really is based off of those double bonds. So remember, we already talked about these two polyatomic ions, the nitrate and the carbonate. So let's look at the nitrate ion. So this polyatomic ion, if you notice, has one nitrogen in the middle. They all possess that +1 formal charge. We have oxygens all around. Now look at these oxygens. This oxygen is the 0 charge. This oxygen has the 0 formal charge, and this oxygen has the 0 formal charge. And the other two get the -1. But technically what we're really looking at is these three oxygens on the left. Bottom left, let's say, would be considered oxygen 1. The one on the top would be considered oxygen 2, and the one to the bottom right would be considered oxygen 3. So if we do look at this oxygen 1 has a single bond and a -1 formal charge, but this oxygen has a double bond and a 0 negative charge. So it's the same oxygen atom, but we really don't know where that double bond is. Is it on the number 2 oxygen? Is it on the 1 oxygen? Or is it on the 3rd oxygen? So a lot of times you're going to see double arrows in between these structures to say, well, really this nitrate ion can exist any one of these three ways because that oxygen, there are technically 3 different oxygens. So here's that double bond that we were talking about. So here's that carbonate. Again, you have carbon in the middle. You have the 3 oxygens on all 3 sides, but technically those 3 oxygens are the same in each of those locations. But that double bond can be in any one of those, and it would be an average of the 3. So that's really all resonance is. So you can draw the one carbonate molecule, but because of that one double bond and the oxygens are all the same element, that double bond can be placed on the first oxygen, the second oxygen, or the 3rd oxygen. That's all, folks.